Children listen, first introduction. See, for example, today our topic is addition modulo n, multiplication modulo n, and for example, addition modulo 5, multiplication modulo 11, likewise, which is a new concept. Listen the concept. First introduction. Okay, introduction is, say for example, 4 addition modulo 5, okay, 3 is equal to, okay, listen, usual 4 plus 3 is equal to 7, that is usual addition. But the today topic is 4 addition modulo 5, 3, which is equal to, here, addition modulo 5 means 4 plus 3 equal to 7. Okay, 4 plus 3 is equal to 7. Then, addition modulo 5 means, your answer is 5 or more than 5 means subtract 5 and multiples of 5. Okay, that is the technique. Here, as usual addition means 4 plus 3 equal to 7. Okay, answer. But it is operation addition modulo 5. Addition modulo 5 means your answer is 5 or more than 5 means subtract 5 and multiples of 5. For example, 4 plus 3 is 7. 7 is more than 5. Okay. Suppose your answer is less than 5 means itself answer. Okay. Here 7 is more than 5, so I want to subtract 5 and multiples of 5. Here 7 minus 5 is equal to, because 1 5 is 5, remainder 2, so it is 1 time. So 5 is 1 time in 7, so that is why 7 minus 5 is equal to 2. So 2 will be the answer, that's all. 2 is the answer. See, for example, suppose one more example, 2, that is 2 addition modulo 5. 2 addition modulo 5, 1, which is equal to, here 2 plus 1 equal to 3, where 3 is less than 5. So that is why itself answer, that's all, which is itself answer. Okay, similarly, which is said to be addition modulo 5. Suppose, for example, addition, that is next operation is multiplication. Okay, multiplication. Suppose, for example, see, multiplication modulo 11. Okay, for our convenience. See, multiplication modulo 11. Just multiplication means as usual multiplication. But it is multiplication modulo 11. Which means, see, for example, suppose 5 addition modulo 11, 4 is equal to, is a question. Okay, now, see, the operation is multiplication. Okay, now 5 4s are 20. 20 is more than 11. Okay, your answer is 11 or more than 11 means I want to subtract 11 and the multiples of 11. Here 5 4s are 20. Okay, listen, 5 4s are 20 and 20 is more than 11. So I want to subtract 11 and the multiples of 11. For example, here 20 minus 11, which is equal to 9. So your answer is 9 will be the answer. So sometimes your answer is less than 11 means itself answer. See, for example, suppose for example 2 addition, that is multiplication. 2 multiplication modulo 11. Okay, 2 multiplication modulo 11, 3 is equal to. Okay, now 2 3s are 6. Where 6 is less than 11, so itself answer. 6 is less than 11, itself answer. Suppose for example, 7 multiplication modulo 11, suppose 6, okay, for our convenience. 7 multiplication modulo 11, 6 is equal to, here 7 6 are 42, but 42 is more than 11. So that is why I want to subtract 11 and the multiples of 11. Okay, I want to subtract 11 and the multiples of 11. Here 7 6 are 42. Okay, 7 6 are 42. So 42 is more than 11. I want to subtract 11 and the multiples of 11. Can you tell me here the nearest multiples of 11? Yes, 1 11 is 11, 2 11s are 22, 3 11s are 33, 4 11s are 44. Okay, 44 is more than 42. So that is why 3 11s are 33. So 3 11s are 33. Now subtract, what is your answer? Yes, 42 minus 33 is equal to, here 7 plus 2 is equal to 9. So your answer will be 9. Okay, and also see, consider these answers are must be less than 11. Okay, so your answers are must be less than 11. That is a technique. Okay, say for example, suppose 11 multiplication modulo 11, 1 is equal to, okay, 11 multiplication modulo 11 1 is equal to, here 11 into 1 equal to 11. So your answer is 11, so subtract 11, that is 1 time. So 11 minus 11 is equal to 0. So 0 will be the answer. Okay, similarly, for example, here, suppose your question is 2 addition modulo 5, 3 is equal to, okay, for example, 2 addition modulo 5, 3 is equal to, here 2 plus 3, 5. And 2 plus 3, 5. 5 means subtract 5. That means 5 minus 5 is equal to 0. So 0 will be the answer. Okay. And also, listen, let Zn be the set of all congruence classes modulo n. Let Zn be the set of all congruence classes modulo n, which takes the values starting with 0 and ends with before element of the suffix. Here suffix is n, its before element is n minus 1. So Zn is the set of all congruence classes modulo n whose elements are starting with 0 and ends with before element of the suffix. So Zn is equal to 0, 1, 2, etc. Here suffix n before n minus 1, that is, which is equal to n minus 1. Complete the floor bracket, that's all. Okay, see for example, suppose Z5, listen, Z5 is the set of all congruence classes modulo 5. Okay, Z5 is the set of all congruence classes modulo 5, which takes the elements starting with 0 and ends with before element of the suffix. Can you tell me what is the before element of the suffix? Yes, 5 before 4. So starting with the 0 ends with the 4 because 5 before 4. So Z5 is a set which has the elements 0, 1, 2, 3, okay. Next element yourself? Yes, 4. Complete the floor bracket. And so these two sets are finite sets. Okay, these are finite sets. Again, Z5 is the set of all congruence classes modulo 5, which has the elements starting with the 0 and ends with before element of the suffix. So these are the technique. Okay, now which is the introduction for your understanding. Okay, now come to question. Listen, verify closure property, that is commutative property, associative property, existence of identity, next existence of inverse for the operation Z5 on the set is, that is a plus 5 on the set Z5. Okay. Verify closure property, commutative property, associative property, existence of identity and the existence of inverse for the operation plus 5 on the set Z5 is a question. Okay. See, using table corresponding to addition modulo 5. Here the operation is addition modulo 5. Addition modulo 5. Okay. Addition modulo 5 means your answer is less than 5 means itself answer. Sometimes your answer is 5 or more than 5 means subtract 5 and the multiples of 5. So which is the concept. Okay, listen the first step. How many questions we are asked to find, count it? Yes, listen, one closer. See, 1, 2, 3, 4, 5. So 5 properties we want to verify. Using table, that is important. Using table. So okay, here solution. Here Z5 is a set and the plus 5 is the operation. Z5 is a set and a plus 5 is the operation. Okay. First let us prepare the table. Before preparing table, I want to define the set. Here set is not given clearly. So we want to write set ourselves. Okay. Here listen. Z5 is a set which is Z5 means the set of all congruence classes modulo 5. And these elements are denoted by the square bracket. Now listen. Let Z5 is equal to let Z5 is equal to, Z5 is a set which has the elements starting with 0 and ends with before element of the suffix. So Z5 is equal to 0, 1, 2, comma, 3, comma, 4. Okay, complete the bracket. Okay, Z5 is a set and a plus 5 is the operation. I want to prepare table. So when we want to prepare the table means, if the set is a finite set, if the set is a finite set, then we want to prepare the table. Sometimes, if the set is infinite set, we can't prepare the table. If the set is a finite set, because countable number of elements, 1, 2, 3, 4, 5, there are 5 elements are there. So if the set is finite set, countable number of elements, then I want to prepare the table. Listen, table preparation is very simple. Table preparation is very simple. Listen, here I want to write the operation addition modulo 5. The operation is addition modulo 5. Now, in first row, I want to write the elements, all the elements. That is, in first row, 0, 1, 2, next yourself, yes, 3, XII, 4. Okay, first row. Next, in first column also, all the elements I want to write. Okay, listen, in first column, 0, 1, 2, 3, 4. Okay, extend downwards. So remember if there is a place or not. Okay, now I want to complete the table. That is important. Listen carefully. I want to complete the table. Yes. Yes, which is the table. Now, first draw the vertical lines. Okay, let us draw the vertical lines. Yes. Then horizontal lines. Horizontal lines, listen. First row, second row, and suppose third row, which is fourth row. Okay, horizontal lines completed. Okay, now I want to fill the table. Using the concept of addition modulo 5. Addition modulo 5 means your answer is less than 5 means itself answer. Sometimes 5 or more than 5 means I want to subtract 5 and the multiples of 5. Okay, which is the technique. Now come to here. Yes, listen. 0 addition modulo 5 is 0. Okay, now simple addition first of all. 0 plus 0, 0. Okay, come to here. 0 plus 1, 1. 0 plus 2, 2. 0 plus 3, 3. Okay, here 0 plus 4, 4. So, first row as it is. Now listen, come to the first column. Here keep it in the mind. Say 0 plus 0, 0. Okay. 1 plus 0, 1. 2 plus 0, 2. 3 plus 0, 3. 4 plus 0, 4. So, first row and first column, fix it as it is. You want to write. We can fill easily. Listen, first row, 0, 1, 2, 3, 4. Okay. Next, first column. First column, 0. Next, 1, 2, 3, 4. Okay. First column filled. Now come to here. Any idea? Yes. Listen. 1 plus 1. 1 plus 1. 1 plus 1 equal to 2. Where 2 is less than 5. So itself answer. So 2. 2 will be the answer. Okay, come to here. Yes, here 1 plus 2 equal to 3. So 3 is less than 5, therefore itself answer. And also your answer must be belongs to the given set. That is important. Listen, the given set has the elements 0, 1, 2, 3, 4. So this table should contain the given elements, not in the given elements. Okay, that is important. So this table is going to fill with the elements 0 to 4 only. That also a technique. And also one more idea, considering any one row or any one column, all the elements should present one time and repetition is not allowed. That also one more idea. Okay. Now as usual, come to here. Yes, 1 plus 3 is equal to 4. 1 plus 3 is equal to 4. Here listen, one say first element, second element, third element, fourth element. So 4 elements are fixed. That is filled in second row and the last one is vacant. Sometimes one can fill the last one, which element is absent, that element you can fill by using shortcut method. Listen here, 1, 2, 3, 4 filled. Okay, which element is absent? Identify. Anyone? Yes, 0 is absent. 1, 2, 3, 4 present. 0 is absent. 0 will be the the last box. And as usual, verification also okay. Okay, verify it. How to verify? Listen, here 1 plus 4 is equal to 5. Your answer is 5. So your answer is 5. So your answer 5 or more than 5 means I want to subtract 5 and the multiples of 5. So 5 minus 5 equal to 0. 5 minus 5 is equal to 0. Here 1 plus 4, so listen, 1 plus 4, 5 and 5 minus 5 is equal to 0. So 0 belongs to the set. That is important. Okay, come to this place. Yes, Paul. Say 2 plus 1 is equal to 3. Itself answer because 3 is less than 5. Next. 2 plus 2 equal to 4. Yes, 4 belongs to the set. Also less than 5. So 4. Next. Here 2 plus 3 is equal to 5. 5 minus 5, 0. 0 belongs to the set. 0 will be the answer. Next. Here 2 plus 4 is equal to 2 plus 4 equal to 6. 6 minus 5 equal to 1. 6 minus 5 equal to 1. One idea. Otherwise, one more idea. In this row, which element is absent? Listen, 2, 3, 4, 0. Present. 1 is absent, so one can fill with by using the technique of absent. Okay, 1 will be the answer. And come to here, this place. Listen, 3 plus 1 is equal to 4. Yes, 4 belongs to the set. Yes, answer is okay. Next. Here, 3 plus 2 equal to 5. 5 minus 5 is equal to 0. Next. 3 plus 3 is equal to 9. 9 is more than 5. So, 9 minus 5 equal to 4, where 4 belongs to the set. Okay. 4 belongs to the set. Next, come to this place. One can fill by using absent. That is, the absent is here 3, 4, 0, 4. Oh, 4 presented twice. So, there is a mistake. Listen again. Here 3 plus 1 equal to 4. Okay. What about here? Yes. 3 plus 3 equal to 6. 6 minus 5 is equal to 1. So 1 is the answer. Because how I can identify means, in any one row or any one column, all the elements of the given set should be present and the repetition is not allowed. Here I found that 4 presented twice, so which is not possible. So that is why I am recalling again. Okay, come to the last place. Yes, the last place as usual. 3 plus 4 is equal to, so yes, which is addition. So 3 plus 4 equal to 7. 7 minus 5 is equal to 2. So 2 will be the answer. Also, identify the absent. Yes, 2 is absent. So which is your required answer? 2. Okay. Similar idea. Here, listen. In the second column, here one box absent. Say, third column box absent. One box absent. One box absent. One can fill by using absent. Otherwise, by as usual addition also, you can fill. Okay, come to here. 4 plus 1. 4 plus 1 equal to 5. 5 minus 5 is equal to 0. And also identify absent. Yes, 0 is absent. Okay, here. 4 plus 2 equal to 6. 6 minus 5 equal to 1. Okay, verify absent. Yes, 1 is absent. Okay, answer. Next step. 4 plus 3 equal to 7. 7 minus 5 is equal to 2. Yes, 2. Yes, 2 is absent. Your answer is correct. Next, come to the last place. 4 plus 4 equal to 8. 8 minus 5 equal to 3. Where 3 is absent in last column. So table is ready. Okay, table is ready. Now, say here downwards there is no place. So I want to move right side. Okay, I want to move right side. So in right hand side, listen, that is axiom 1. First one. First one is closure property or closure axiom. Closure axiom. Closure axiom. Okay, closure axiom. See, to prove closure axiom, the technique is all the elements in the composition table. Because here, here the operation is defined by some rule. Just plus means addition, normal addition. But here, addition modulo 5 is a rule. So that is why this table is known as composition table. Okay. See, ordinary addition means addition table. But it is defined by some rule, therefore it is addition modulo 5 is operation, therefore this table is known as composition table. Okay, listen. Here all the elements of the, all the elements in the table are the elements of the given set. Okay, so all the elements in the table are the elements of Z5. All the elements. All the elements in the table. all the elements in the table are the elements of Z5. All the elements in the table are the elements of, or one can write this, I told already the keyword, all the elements in the composition table, which is not just a addition table, which is a composition table, one can recorrect, no problem. So all the elements in the composition table, all the elements in the composition table, all the elements in the composition table are the elements of Z5, are the elements of, are the elements of Z5. Therefore, closure axiom is true. Therefore, closure axiom is true. Closure axiom is true. Okay, first topic is completed. Now come to topic 2. Topic 2 is, as per the question, commutative property. Okay, commutative property. Commutative property or commutative axiom, anyone? Okay, commutative axiom. Commutative axiom. From the table, the commutative axiom is true. Okay, and one can give example also. Okay, from the table. From the table. From the table, the commutative axiom is true. From the table, the commutative axiom is true. Okay, one can give example. Say for example, from the table, suppose, for example, 2 plus 3 you take. 2 plus 3. So that is, listen, for example, 2 addition modulo 5, 3. Okay, for our convenience, we are selecting any two elements. 2 addition modulo 3, which is equal to, okay, 2 plus 3 equal to 5. And 5 minus 5 equal to 0. So 0 will be the answer. Let it be the first equation. Next, it's a reverse addition. That is, commutative means A star B equal to B star A. 2 plus 3 equal to 3 plus 2. Likewise. Now its reverse addition is given by 3 addition modulo 5, 2, which is equal to 3 plus 2 equal to 5. 5 minus 5 equal to 0. So, which is 0. Let it be equation number 2. From 1 and 2 it is clear that RHS are equal, therefore LHS are equal. That is, listen, 2 addition modulo 5, 3 is equal to 3 addition modulo 5, 2. Yes. Therefore, already we told commutative axiom is true. So, which is example. Okay. It is for example. Example is ready. Children listen. Now, associative axiom. Okay. Here, to prove that is, we know that from the table, associative axiom is true under addition modulo 5. Okay. That is, from the table, addition modulo 5 is always associative. Okay. From the table, addition modulo 5 is always associative. One can give example. Say for associative axiom, we want to take 3 elements. See for example, consider 1 addition modulo 5 bracket 2 addition modulo 5 3. Okay, complete the bracket, which is equal to. Okay. Now first see it is of the form. What is associative axiom? A star B star C equal to A star B star C. Here last two are in the bracket, and I want to prove first two in the bracket. Okay, that is associative axiom. I am taking LHS of the associative. First complete the bracket answer. Okay, can you tell me what is your bracket answer? Yes, 2 plus 3 5. 5 minus 5 equal to 0. So which is equal to 1 addition modulo 5 and 2 plus 3 5. 5 minus 5 is equal to 0. So which is the answer is 0. Okay, which is equal to now 1 plus 0. 1 plus 0 equal to, yes, 1. 1 is less than 5. Therefore, itself answer. So your answer is 1. Let it be the first equation. Okay, which is first equation. Now change the bracket. Change the bracket means, listen, 1 addition modulo 5, 2. Okay, bracket, addition modulo 3. because we want to take the elements, that is take the elements, that elements should be belongs to the given set, that is important. Okay, come to the syllabus, which is equal to, first complete the bracket. Yes, 1 plus 2 equal to 2. 2 is less than 5, so itself answer. Your answer is 2, bracket answer is 2. Addition modulo 3. Okay, now which is equal to, here again there is a mistake. 1 plus 2 equal to 3. Remember, okay? No problem. 1 plus 2 equal to 3. 3 is less than 5, so itself answer. Next 3 already fixed. 3 plus 3 equal to, yes, 6. 6 minus 5 is equal to 1. So your answer is 1, which is second equation. Now from 1 and 2, RHS are equal, therefore LHS are equal. From 1 and 2. From 1 and 2 it is clear that that is 1 addition modulo 5 bracket 2 addition modulo 5 3 which is equal to, change the bracket, that's all. That means moon bracket 1 addition modulo 5 2, okay, bracket addition modulo 5 3. Therefore associative axiom is true. Therefore associative axiom is true. Okay, therefore associative axiom is true. Third property is completed. Okay, come to next one is what? Say closure axiom, commutative axiom, and associative axiom. Next existence of identity. Okay, existence of identity or identity axiom, any one way. Suppose identity axiom. Subreason 4 is identity axiom. Identity axiom is a topic. Okay. Now, say to answer identity axiom, we want to listen the table. Okay, listen the table. We know that additive identity is 0. We know that additive identity is 0. So from the table, the identity element is 0. Okay, from the table, the identity element is 0. Okay, from the table, the identity element is From the table, the identity element is 0 belongs to Z5. That's all. So answer is completed. Children listen. Now the fourth topic is inverse axiom. Not fourth topic, that is topic 5. Okay. Fifth topic is inverse axiom. Okay. See, we know that inverse axiom gives identity answer. That is important. Inverse axiom gives identity answer. Now from the table, wherever the identity is 0, we want to encircle, because already we know that about identity. Additive identity is 0. Okay. Now inverse topic gives identity answer. Now listen, in the first row 0 is the answer. Encircle using pencil. Okay, 0. Next, first row 0. Next is in second row. Yes, there is a 0. In third row, yes, which is a 0. Next, in fourth row, yes, 0. In fifth row, yes, 0. Now listen, already I told inverse topic gives identity answer. Now the technique is keep the finger in the identity 0. Now your answer is inverse of 0 is 0. That's all. Okay. Come to this place. Okay. Now start your answer yourself. Yes. That is, listen, keep the finger here. Inverse of 1 is, listen. Inverse of 1 is 4. Okay. Next, here. Listen. Inverse of 2 is 3. Okay. Similarly, yourself. Yes. Inverse of 3 is 2. Okay. Come to here. Yes. Inverse of 4 is 1. That's all. Answer over. Now listen, the answer is, that is inverse of 0 is 0. Inverse of 0 is 0. Okay. Next, similarly, inverse of 1 is 4. Inverse of 1 is 4. Next, inverse of 2 is 3. Inverse of 2 is 3. Next, inverse of 3 is 2. Inverse of 3 is 2. Next, now yourself. Yes. Inverse of 4 is 1. Inverse of 4 is 1. Therefore, inverse axiom is true. Inverse axiom. Inverse axiom is true. Okay. Then here inverse axiom. Inverse axiom is fifth topic. Okay. Inverse axiom is fifth topic. Okay. So which is the required answer? Children listen. Now example 12.10. Verify closure property, commutative property, associative property, existence of identity, existence of inverse for the operation multiplication modulo 11. Okay. See, this multiplication modulo 11 can be rewritten as that is multiplication modulo 11. Also correct. Okay. Operation is multiplication modulo 11 on a subset A is equal to 1, 3, 4, 5, 9 of the set of remainders 0, 1, 2, 3, etc., 10. Okay. So your answer is 11 or more than 11 means subtract 11 into multiples of 11. Then you are going to get the remainders 0 to 10. So that is a meaning. And your answer is exactly 11 means 11 minus 11 equal to 0. That is right. Suppose your answer less than 11 means itself answer. Okay. Equal to 11 means 11 minus 11 0. Okay. Here, see, they told the subset A. Okay. The remainder set 0 to 10. Say don't take this set. We want to take the given set A. Okay. Now listen. The given set is A set is equal to A set as the elements. A set floor bracket. A set as the elements 1 comma. Here they left a bracket, so we want to write a bracket ourselves. So the set A is equal to 1 comma 3 comma 4 comma okay 5 comma 9. That's all. Complete the floor bracket. And also here A is a set and multiplication modulo 11 is the operation. So that is very, very important. Okay. Remember here A is a set and the multiplication modulo 11 is a set. Okay. Now which is a finite set? I want to prepare the table. Okay. Table preparation is very simple. Table preparation. Listen. Table preparation. Here multiplication modulo 11 is the operation. Okay. Now start. Write the elements 1, 3, 4, 5. Listen. 1, 3, 4, 5 and the last element is 9. Okay. Extend. And here column wise. Column wise also 1 is not 2. 1, 3, 4, 5. 1, 3, 4, 5. Okay, 1, 3, 4, 5, 9. Now complete the table. Listen, complete the table. First, column wise, complete the table. Say, now row wise. Okay. Table ready. Now, see, as usual, we know that first row as it is, first column as it is. Okay, start. If and doubt means verify, no problem. Here 4, see, 1, 3, 4, 5, 9. Next, here first column as it is, 1, 3, 4, 5. If and doubt means verify. Okay, come to here. Here 3 3s are 9 because multiplication operation. 3 3s are 9. 9 belongs to the set. Yes, 9 belongs to set. Here 3 4s are 12. 12 minus 11 equal to 1. Okay, here that is 3 5s are 15. 3 5s are 15. 15 minus 11? Yes, very good. 4. Okay, here that is 3 9s are 27. 27 minus 22 because multiples of 11. So 3 9s are 27, 27 minus 22, 27 minus 22 is equal to 5. Also verify option, yes option 5. Okay, here 4 3s are 12, 12 minus 1, 1, 12 minus 11, 1. Okay, here 4 4s are 16, 16 minus 11, 16 minus 11 is equal to 5. Next, here 4 5s are 20, 20 minus 11 is equal to 9. Okay, next here 4 9s are 36. 36 minus 33, so which is equal to 3. Remember here, 5 3s are 15. 15 minus 11. 15 minus 11 is equal to 4. Next, 5 4s are 20. 20 minus 11. So is equal to 9. Next, 5 5s are 25. 25 minus 22 is equal to 3. Next, 5 9s are 45. 45 minus 44 is equal to 1. Because 44 is the multiples of 11. Next, one can write absent also. Listen, here I think 5 is absent. Okay? Yes, 5 absent. Here, in this column, I think 3 is absent. Okay, one can fill by using absent also. Here, which is absent? Yes, 1 is absent. Here, the absent is, I think 4 is absent. Okay, say, now, listen to the technique. Here, multiplication is an operation. So, multiplicative identity is 1. Multiplicative identity is 1. 1 belongs to A. Therefore, identity axiom is proved. Okay, next inverse axiom. Inverse topic gives identity answer. Inverse topic gives identity answer. Wherever identity, I want to encircle. Listen, see, identity 1, multiplicative identity 1, identity 1. Next, identity element is 1. Next, identity element is 1. Here, identity element is 1. Okay. Now listen, keep the finger here. Inverse axiom. That is, inverse of 1 is 1. Over. Come to here. Inverse of 3 is 4. Next. Inverse of 4 is 3. Next. Listen. Inverse of 5 is 9. Next. Here 1 is available. Inverse of 9 is 5. So inverse axiom ready. From the table one can answer identity axiom and inverse axiom directly. Multiplicative identity 1 belongs to A. So identity axiom true. Then inverse axiom, all the elements as unique inverse. Okay. These 2 topics completed. Now, as usual, closure axiom. Closure axiom. All the elements in the composition table are the elements of A. Therefore, closure axiom is true. Next, associative axiom we want to verify. And then identity. Also, we have commutative axiom. Commutative axiom. From the table, commutative axiom is true. Okay, likewise. Now let us start our answer. Listen, subdivision 1. Subdivision 1 is closure axiom. Closure axiom. Closure axiom. All the elements in the composition table are the elements of A. All the elements in the composition table are the elements of A. Therefore, closure axiom is true. Closure axiom is true. Okay. Now subdivision 2. Subdivision 2 is commutative axiom. Commutative axiom. Okay. To prove commutative axiom, select any 2 elements. See, for example, here 1 and 3 is available. Why not? You take 1. See, 1 multiplication modulo 11, 3. Okay. Which is equal to 1 into 3 equal to 3. And where 3 is less than 11. So itself answer. Now, it's reverse multiplication. 3 multiplication modulo 11. Okay, 1. 3 into 1 equal to 3. Which is equals number 2. From 1 and 2 it is clear that. RHS are equal, therefore LHS are equal. Which means 1 multiplication modulo 11, 3 is equal to 3 multiplication modulo 11, 1. Yes, therefore commutative axiom is true. Therefore commutative axiom is true. Okay. Children listen. Now subdivision 3. Subdivision 3 is associative axiom. Associative axiom or associative property. Listen, from the table, multiplication modulo 11 is always associative. Okay, but if we want to give example, say for example, let us take 3 elements, 1, 3, 4. Okay, listen, 1 multiplication modulo 11 bracket 3 multiplication modulo 4. Okay, complete. We are taking 1, 3, 4, which is equal to, first complete the bracket answer. Here, 1 multiplication modulo 11 and 3 4s are 12. Here multiplication modulo 11, important. Okay, 3 4s are 12. 12 minus 11, 1. So your answer is 1, which is equal to 1 into 1, 1. 1 is less than 11. So itself answer. So 1 is answer, which is equation number 1. Okay, change the bracket. That is 1 multiplication modulo 11, 3 bracket multiplication modulo 4, which is equal to bracket answer. Yes, 1 3 is 3. 1 3 is 3 multiplication modulo 11, 4. Okay, now 3 4s are 12. 12 minus 11, 1. So which is equation number 2. From 1 and 2 it is clear that From 1 and 2 it is clear that RHS are equal, therefore LHS are equal. Therefore 1 multiplication modulo 11 bracket 3 multiplication modulo 11 4 is equal to, change the bracket. Change the bracket means 1 multiplication modulo 11 3 bracket, okay, multiplication modulo 11 4. Therefore associative axiom is true. Therefore associative axiom is true. Okay, next step, which is after fourth subdivision, that is identity axiom. We know that multiplicative identity is 1. Therefore, from the table, the identity element is 1. That's all. From the table, the identity element is. From the table, the identity element is 1, belongs to A. Therefore, identity axiom is true. Enough. Children, listen. Now, fifth topic, inverse axiom. Inverse axiom. From the table, say inverse of 1 is 1, inverse of 3 is 4, inverse of 4 is 3. Next, inverse of 5 is 9. Here, inverse of 9 is 5. Okay, already we discussed about this. Now, from the table, inverse of 1 is 1. Next, listen. Here, inverse of 3 is 4. Next, here, inverse of 4 is 3. Next, inverse of 5 is 9. Next, here, inverse of 9 is 5. Therefore, inverse axiom is true.